Welcome to the Explainer. Listen, if you're a BIM professional, a CAD specialist, or a computational designer, we really need to have a serious talk about how you're actually using AI right now. Most of the industry is still treating large language models like a glorified search engine. But to actually drive real productivity in Revit, Dynamo, or C#, you've got to stop treating AI like Google and start treating it as an automation engine.
Exactly. I can't even tell you how many BIM managers I know who just type, "Give me a Dynamo script to make walls," into an AI. They get a script that completely crashes their model, and then they immediately declare that AI is basically useless for construction tech. Well, today we're going to fix that.
Okay, let's run through our agenda real quick. First up, the AI foundation. Then, climbing the prompt ladder, moving into advanced reasoning and debugging, scaling up with enterprise agents and workflows, and finishing off with your 13-level roadmap. We are totally focused on practical, verifiable methodologies today. Let's jump right in.
Section 1. The AI Foundation. Setting the ground rules. So, before we even think about writing a single line of prompt text, we absolutely have to establish the correct mental models, because if you don't understand how the engine works, you simply cannot steer the car. There's a core rule from our source materials we need to internalize. The quality of the AI's output is a direct mirror of the quality of your input. Garbage in, garbage out is the golden rule. I've been instructing in construction tech for over 20 years, and I see this literally every single day. Prompt engineering isn't just some optional side skill anymore. It is the absolute difference between AI being a massive productivity multiplier or just a source of immense frustration.
Right. And this brings us to what was honestly a massive light bulb moment for me. Realizing that an LLM is essentially a supercharged autocomplete. I mean, it's a probabilistic pattern matching engine. Understanding that completely changed my daily workflow. You see, the AI cannot actually see your Revit model. It doesn't inherently know what a curtain wall or a structural column is in a 3D space. It just encodes statistical relationships between words. Because it can't see the model, and it sure can't read your mind, you have to meticulously steer that pattern matching engine using your own domain expertise.
Precisely. And steering it? Well, that starts with the actual settings. A highly actionable takeaway for you right now is managing the AI temperature, which is what controls the randomness of the output. If you are generating a Dynamo script or querying the Revit API, you absolutely must lower the temperature to somewhere between 0.0 and 0.2. You want highly predictable, deterministic code so you can avoid hallucinations entirely. If you leave it at, say, 0.7, you're going to get hallucinated Python nodes that try to invent brand new laws of physics inside your model. Save that 0.7 temperature for things like writing BIM execution plans or brainstorming project proposals.
Section 2. Climbing the prompt ladder. Escalating complexity for Dynamo.
Let's use a really relatable problem here. Renaming sheets in Dynamo. It's a classic task, right? But how do we get the AI to write a script that actually works on the very first try instead of spending an entire hour troubleshooting pure nodes?
You get it right by climbing what we call the prompt ladder. This is a systematic progression. You go from bad to good to expert to production and finally to master. And each level doesn't just, add more words to the prompt. It systematically adds specificity, constraints, and vital context. Let's actually look at the difference between the bottom and the top of this ladder.
The gap between these two approaches is wild. A bad prompt just says, act as a senior BIM automation specialist, generate a Dynamo script to rename sheets. The persona there is incredibly shallow, and there are literally no safety constraints. But a production prompt? Now we're talking. We add a prime directive, like never use deprecated methods, always verify code for syntax errors. We deepen the persona by telling it, you are a defensive programmer who assumes worst-case inputs, and you write scripts that can be safely run by junior coordinators without supervision. And finally, we give it a highly specific task. Whether it's renaming sheets, creating levels, or generating complex curtain walls, we are actively giving it stakeholder context and incredibly strict error handling rules.
Okay, but here is my big question as a practitioner. That production prompt is awesome for a standard everyday project. But what happens when that Dynamo script needs to reliably process 1,000+ sheets on a massive, complex hospital project without completely crashing Revit? How in the world do we scale the AI's logic for those kinds of high-stakes environments?
Right. So for that, you need an expert prompt that commands advanced reasoning strategies. You don't just ask for a script anymore. First, you use chain of thought. This forces the AI to explain its logic step by step before it even writes a line of code. Then, tree of thoughts. You command it to consider multiple different approaches. So maybe evaluating a Python script against pure nodes for a complex COBie data extraction and listing the pros and cons of each for that massive dataset. Next is self-consistency, where it generates different versions of the solution and compares them. And finally, reflection, where it reviews its own chosen approach for potential bottlenecks. You are literally forcing the pattern-matching engine to verify its own logic before it ever touches your real project data.
Moving on to Section 3, Advanced Reasoning and Debugging, Fixing Revit API Errors. Let's just be brutally honest here. Even with a really great prompt, things are going to fail. When I'm dealing with the Revit API, compilation errors are basically inevitable. So, how do we handle that? You handle it by treating debugging as a true engineering discipline. We use the DEBUG framework from our sources. D, define the symptom. For example, the code just doesn't compile. E, examine the prompt. Did I actually specify which year's version of the Revit API I'm targeting? B, build a hypothesis, like, I missed the version year, so it's probably using an outdated method. U, update the prompt. And finally, G, gauge the result. We have to stop blindly guessing, using hope and pray debugging, and just throwing massive error logs at the AI hoping for a miracle. Systematically check your API limitations.
Section 4. Enterprise Agents and Workflows, Scaling Beyond the Individual.
Now, if you master individual prompting, you are going to be an incredible individual contributor. But eventually, we need to shift our focus to deploying these systems across a whole BIM department or a global firm.
Right, and this is where we start hearing that buzzword, agents. And based on the research from Anthropic and our sources, an agent is not just a simple chatbot. It is an augmented LLM. This means it's equipped with specific tools, and it can dynamically direct its own processes. So it begins with a command, it plans out its steps, and then it executes a tool call to run code. Most importantly, though, it pulls ground truth data from the environment. Like it can check actual clash detection results via an IFC export to assess its own progress before moving on to the next step.
Exactly. And to deploy these augmented LLMs safely, you really need the enterprise prompting mindset. Think about how we handle BIM execution plans or ISO 19650 standards. We don't just let everyone go rogue and do whatever they want. Enterprise prompting is exactly the same thing, just for AI. You have to build systems over individual skills. Your prompts must be treated exactly like code, meaning they are versioned, tested, and auditable templates. You need real governance, like who actually approves a prompt that does automated quantity takeoffs. You need continuous improvement to track the quality, usage, and cost of these outputs over time.
Section 5. Your 13-level roadmap, the path to AI mastery. So if someone watching this explainer wants to roll up their sleeves and actually implement all these frameworks into their daily CAD workflows, what does that path actually look like?
Well, the curriculum journey maps out perfectly for this. You start with the fundamentals in levels 1 through 3, where you're mastering context, persona, and prime directives, making sure you have that solid baseline. Then intermediate levels 4 through 6 cover structured output and few-shot prompting, where you provide the AI with specific input and output examples. Then we get to advanced, levels 7 through 9. That's where you learn reasoning strategies, retrieval augmented generation, and that debug framework we just talked about. Finally, expert and master levels 10 through 13 cover building AI agents, scaling enterprise prompts, and completing a capstone project. And remember, this entire curriculum is super interactive, heavily utilizing quizzes and mini projects at each stage, so you are actively building the skills, not just watching videos.
So here is the crucial point, and the main takeaway we want to leave you with today. Look at your own workflows right now. When you write your very next prompt for Revit or Dynamo automation, are you going to treat it like a casual search query, or are you actually going to engineer it like code? We are challenging you right now. Take the absolute worst, most frustrating prompt you've written recently and just rewrite it using one technique from this explainer. Add a prime directive, lower that temperature to 0.1, or ask it for a step-by-step chain of thought. Try it out. The results will literally speak for themselves.